Let's solve part C now. So the question is, when do we break even? So break even. Break even means we have zero profits. We have zero profits. Now what is profit? Profit is the difference between what we make, total revenues, minus what it costs us, minus total costs. And that has equals to zero. So if total revenue minus total cost equals to zero, that means that total revenue must equals to total costs. Must equals to total costs. So that's what we're looking for. Now, when does this hold? Well, let's see. We have our total revenue function, we have our total cost function. Total revenue is equal to 107q minus 2q squared. And total cost is equal to 200 plus 3q. That was given in the question. Okay, so from here we could write that 107q minus 2q squared, q minus 2q squared must equal to 200 plus 3q. So how can we solve it? We have a quadratic term here, which means it would be nice to have it as a quadratic equation so we can solve it with delta. Well, if we want to have it as a quadratic equation, let's take all the terms to the left and equals to 0. So 107q minus 2q squared minus 200 minus 3q equals to 0. Let's solve this. So let's write the quadratic term first, just because it looks better, minus 2q squared. And then we have 107q minus 3q, that's plus 104q minus 200 equals to 0. Okay, that's our quadratic function now, because we have our a, our b, and our c. Remember, the coefficient next to the squared term is our a. The coefficient next to the term with the power of 1 is b, and the constant is just the constant, right? Minus 200 in this case. And make sure always to look at the sign, because the constant is the whole number, so it has to have the sign as well. Is it a negative number or is it a positive number? The same goes here. Sometimes it could be minus 104, so make sure to take the sign into account. And the same goes with the coefficient here. Take the sign as well into account. Okay, we got a, b, and c. Let's delta it. Let's do the delta. Alright, so delta equals to 104 to the power of 2 minus 4 times minus 2, which is a, times c, which is minus 200. Alright, delta equals 2. So let's actually calculate it. That will be equal to 2000. Hold on a second. Alright, so that's equal to 9,216. 9,216. Okay, let's solve for the q. So we want to know the possible q values. Okay, q1 equals to minus b minus square root of delta divided by 2 times a. So that's equal to minus, what was b? 104. 104 minus square root of 9,216 divided by 2 times a, which is 2 times a, which is minus 2. Alright, so we have minus 104 minus square root of 9,216 equals to 96 divided by 2 times minus 2, which is minus 4. Minus 104 minus 96, that's equal to minus 200 divided by minus 4. Well, minus 200 divided by minus 4 equals to 50. So we got 50 as one answer. And now the second answer is equal to q2 equals to minus b plus square root of delta divided by 2a, which is minus 104 plus square root of 9,216 divided by 2 times minus 2, which is equal to minus 104 plus 96 divided by minus 4, and that's equals to minus 104 plus 96, Well, that's minus 8 divided by minus 4, and that's equal to 2. So we found the possible quantities that make us break even. That's it. When we sell 2 units, we break even, and then when we sell 50 units, we break even as well. Now let's show this on a graph in part D, just to wrap it up and to understand how it all makes sense in the end. So in part D, if we have a function between profit and quantity, that's our quantity and that's our profit, and let's say it goes like that. It goes actually that's better to call it total revenue, total cost, because we'll have 2 graphs. So in the first case we would have total revenue, which we drew before. It goes up and then it goes down, right? And we have a maximizing value. And then we also have the total cost function, which is 200 plus 3q. Well, what is 200? That's the constant, that's the y-intercept. So we start to have 200 plus 3q, which goes like that. 200 plus 3q. Well, if this is total cost and the yellow part is total revenue, when do they equal? Well, they equal at this point and they equal at this point, which means that here is where we break even. And what are the values where we break even? We just found out. They are 2 and 50. So we could write down here that we have the value of quantity of 2, the value of quantity equals to 50, and that's where we break even. Now, what happens in this area? Well, we can see that the value of the total revenues, let's take this point over here. Let's say this is the quantity equals to, let's call it 17, for instance. So at the quantity of 17, the total revenue has a higher value than the total costs. This is going to be the total costs, and this is going to be the total revenue. Well, if the total revenue is higher than the total costs, it means we're making a positive profit here. So that's good, we're making money. And across all this area, between total revenue and total costs, the profit is going to be positive. But at these exact points, the profit is just 0, we're breaking even. And on these parts from 0 to 2 and above 50 is the opposite. The total cost is higher than the total revenue. Let's take a point. Let's take this one. Let's call it 52, for instance. Well, at the point of 52, the total revenue is just here. Is just over here. But then what is the total cost at that value? Well, at the 52, the total cost goes higher. It goes over there. So this point is above the total revenue. This difference is negative because we have total cost minus total revenue. Total cost is higher, and if the cost is higher, that means that the profit is negative. I hope this makes sense. We are done.